This is Algebra 1, Homework 1-6 video solutions for distance, rate, and time word problems. So we have 6 word problems. We have the answers on the back. Let's go ahead and jump in. All right, so we have two different types of equations that we can be using in this entire worksheet. I'd like to go over them now. The first is distance is equal to distance, and the other one is, let's go here and say distance 1 plus distance 2 is equal to the distance total. And as a reminder, the way that we find distance is we multiply rate times time. So generally speaking, we only do distance plus distance when two people are traveling in opposite directions. Otherwise, you're always using distance is equal to distance. So we have Carlos. He's leaving a mall and he's traveling north. And there's a speed traveling north. Dan left in the somewhat later, traveling in the opposite direction. So if there's two people traveling opposite directions, this is the case where we're doing distance 1 plus distance 2 is equal to the total distance. So that's generally how I always start out these problems, is nice and simple. It's like, okay, it's one of the two things, Mr. Sandell. It's distance 1 plus distance 2 is equal to the total distance. And then I will replace this with the rate 1 times time 1 plus rate 2 times time 2 is equal to the distance total. So we're just, again, this one can be a rate times time, but I usually leave it distance total. We can fill in usually to these to see what we have. Oh, actually, we have the distance apart. The total distance is going to be 610 for down here. So let's go ahead and fill in what we know. We know this one is going to be 610. What else do we know? Let's go ahead and assume that Carlos is going to be the person that we're talking about for number 1, and we're going to assume Dan is going to be number 2 in terms of our variables down here. So those are 1s, those are 2s, 2s are for Dan. So Carlos, we have Carlos's speed. Carlos's speed is 52, so this 52 is going to be the rate or the speed for Carlos. We're going to say that this is going to be 50, I want to do this in blue. This is going to be 52 times, we don't have his time yet, but let's go ahead and do plus, what other information do we have? Left somewhat later, I don't know if that's going to help us, in the opposite direction. That's how we know we have distance plus distance. And okay, so Dan is traveling at 70 miles per hour, so that's the second rate. So we'll come down here and say that this is 70 miles per hour, multiplied by some sort of time. Okay, we don't have either of these two variables. We need one of them, otherwise we need a second equation. So what do we have? After Carlos traveled for 5 hours. So that means Carlos is traveling for 5 hours. Remember, Carlos is number 1. So 5 hours is going to be time 1. You come down here and say 5 hours for Carlos. And we are looking for, find the number of hours Dan traveled. So we're looking for number of hours or time for Dan, which is 2. So we're just going to leave this as T2. You can call it T if you want, for X, or any variable that you want. I'm going to keep mine T2 because that reminds me that just like in future cases, sometimes I'll have two different variables and it's hard to distinguish between T and the other T. So it's just a habit to get into. So how do we solve for this T2? We simplify. So I'm going to do 52 times 5, and then I'm going to rewrite that. So what do we got here? 52 times 5. Well, 2 times 5 is 10, so I do the 0, carry the 1. 5 times 5 is 25, plus the carried 1 is 26. So I have 260 plus 70 T2. That's going to be equal to 610. So from here, we see that we have one variable, which means this left-hand side is the variable side, and this right-hand side should be the constant or the number side. This is a constant, which means it belongs on the right-hand side. Let's go ahead and subtract 260 from both sides. So let's get another color here. Subtract 200. Oh, that's not 260. Slight dyslexic moment there. Minus 260 on both sides. What do we have here? We have 70 T2 on the left-hand side. On the right-hand side, now we have, what is that going to be? 350. And then the last thing we need to do is to get rid of the 70. Right now the 70 is being multiplied by T2, so the inverse operation of multiply is divide. We're going to divide by that coefficient, 70. So when we do that, the 70s are gone, and we get T2, which is going to be our answer. And here's how I think about these problems. I see the 0 and 0, and I kind of cross them out, which is the equivalent of dividing the top and bottom by 10. So that's the rationale for my rule, but I never really think about that. I just cross out the 0. And then my new question is, what's 35 divided by 7? 35 divided by 7 is 5. So I say that my final answer here is 5. And again, you don't just box this and call it a day. You need to interpret the question. So what were we trying to find? We were trying to find a number of hours. So this is 5 hours. So we'll go ahead and write 5 hours out here to the side and box our interpretation. And finally, we check our work. On number 1, yep, it's 5 hours. We got it right. So we come back here and we highlight this in green. All right, that was question 1 of 6. Let's move on to number 2. So we have Mark and Noriachi leaving a hardware store at the same time. So if it's the same time, that makes our life a little bit easier. Opposite directions. So opposite directions, again, that's going to be distance 1 plus distance 2 is equal to the total distance. Let's go ahead and mark that right now so we don't make any mistakes. We know we're going to be doing distance 1 plus distance 2 is equal to the total distance. And we might as well convert that as well. We know distance is rate times time plus rate times time. And this one is rate 1 times 1, rate 2 times 2, and that's going to be, again, equal to the total distance. So let's go ahead and fill in what we know from this question. They drove in opposite directions. That gave us this equation. Let's say Noriachi is 1, just because he's the first piece of information that we actually care about. So Noriachi is 1, which means Mark is going to be 2. So if Noriachi is driving 15 miles per hour faster than Mark, I don't know if that helps us yet. I can't plug in a speed. It doesn't say he's traveling 15 miles per hour. It's 15 miles per hour faster than Mark, and we don't know how fast Mark is going. We do know this. After 5 hours, they were this distance apart. So the total distance is going to be 425. This number is going to come over here. We're going to say this is going to be equal to 425. And since they both left at the same time, that means they've been traveling for the same amount of time. So 5 hours is going to be for both time 2 and for time 1. So let's go ahead and plug those in. It's going to be 5 here, 5 here. There's a plus here, multiplication symbol there. The problem is we don't have any rates here. So for lack of anything else, we just have to rewrite rate 1 and rate 2. And it's kind of sad. We have one equation, we have one equal to sign, but we have 2 different types of variables. If you have 2 different types of variables, you need 2 different equations, and we only have one equation. So to find a second equation, we need to use the other piece of information that we haven't used so far, which is this. Noriachi drove 15 miles per hour faster than Mark. So how do we say that in terms of an equation? Usually, we always say some big amount minus some small amount is equal to the difference of their amounts. So which one is bigger? Which one is traveling faster? Is Noriachi traveling faster or is Mark traveling faster? It says Noriachi is driving faster, so we're going to say Noriachi is the bigger one. We're going to say this speed 1 or this rate 1. I'm going to say rate 1 minus the rate 2. Rate 1 is the bigger one because Noriachi is 1. And that's going to be equal to the difference. What's the difference? Their difference is 15 miles per hour. So I'm going to say is equal to 15. So this is the second equation. I said there's one equation, now there's 2 equations. I'm going to somehow use this first equation and substitute in for either R2 or R1. And it doesn't really matter which one I choose, but because the question is asking me to find Mark's speed, remember Mark is number 2, it would be really helpful for me to solve for R1, the other one, because that's the one that'll cancel out. You don't have to do it this way, and I can prove maybe in a future question that it doesn't matter, but to go as fast as possible, I'm going to, this is Mark's speed, and I'm going to solve for the other person's speed, Noriachi's speed. I'm going to add R2, add, well, I guess I should do it over here to the right, add R2. I usually only add things underneath if they are like terms, but R is not a like term with 15, so I kept it off to this right-hand side. Notice that you'll have an R2 and an R2 that will cancel each other out, leaving you with R1 is equal to 15 plus R2. So if I have R1 is equal to 15 plus R2, this R1 is also equal to 15 plus R2. So I'm going to take this 15 plus R2, substitute it in for R1, and I'm going to get my new equation. So I have, in parentheses, because I'm doing substitution, 15 plus R2, end the parentheses, and rewrite everything else. So everything else was times 5 plus R2 times 5 is equal to 425. And I want to make a special note on this problem, and I'm probably not going to talk about this for the rest of the video, which is it's super important to keep the parentheses whenever you do substitution, because whenever you have multiplication, this is now going to be distributed twice. If you forgot the parentheses, you might only think the 5 is being multiplied by the R2, but it should also be multiplied by the 15. If you keep your parentheses, you shouldn't make any mistakes every time you do substitution. So from here, we are going to do exactly that. We're going to distribute the 5 times 15. What is that going to be? Well, 5 times 5 is 25, and carry the 2. 5 times 1 is 5, plus the 2 is 7. So 75 plus, and then I'm going to distribute the 5 into the R2. I'm getting 5 R2 plus, okay, 5 times R2 is, again, another 5 R2. And keep the right-hand side the same. This is going to be 425. From here, we're going to add our like terms. We have an R2 and another R2, so adding those together, we add their coefficients, 5 and 5. 5 and 5 makes 10, so I have a total of 10 R2. And it's a positive, so I'm going to put plus sign out front. We still have the 75, which I will rewrite, and that's still equal to 425. This is now a very simple equation that we can solve. So notice that we have the left side with a variable, which means, and the right side without a variable. Let's reserve the left side for a variable, meaning that we need to move this constant to the right side, since all of the right side should be for our constants or our numbers. So I'm going to subtract 75 from the left, which means I also have to subtract 75 from the right. Notice that I'm drawing it right underneath the 425 because these are like terms. When I do that, I'm left with 10 R2 is equal to 350. And then from here, I need to undo multiply by 10. I'm going to divide by 10. Divide the left side by 10, divide the right side by 10. And again, this is one of those tricks I was talking about before, where you cross off a 0, and this is going to be R2 is equal to 35. So don't box your final answer. That's not your final answer. Don't box this interpretation because we haven't actually interpreted the full problem yet. So what is R2? R2 is talking about Mark, because Mark is 2, and R is a rate or a speed. It is Mark's speed. And speed in this problem, it's not measured in miles, it's measured in miles per hour. So our final answer is going to be Mark's speed is 35 miles per hour. And be careful on these types of problems, because maybe you accidentally solved for R1. If you accidentally solve for R1, you have to come back to this equation to figure out what R2 is. But in this case, I didn't have to do that because I was smart in how I solved for R1 at the very beginning. And let's go ahead and check our work. Is the answer 35 miles per hour? The answer is indeed 35 miles per hour. So we're 2 for 2, doing pretty good. All right, let's try number 3. It should be a new type of problem. Usually make adjacent problems the same, that way you get some good practice. All right, in problem number 3, we have Kim making a trip to her cabin and then back. So if it's a trip there and back, it's the same distance there as the same distance back. So it's going to be a distance is equal to distance. So let's start nice and easy and just say that this is distance is equal to a distance. And then fill in what distance is. Distance is equal to rate times time, and distance is equal to rate times time. It's kind of nice for these equations because there's only 4 variables versus the last equation where there are 5 variables. 1, 2, 3, 4, 5. Okay, so on these types of problems, we need to identify our variables a little bit better. So I'm going to say that the trip there is going to be 1, and our trip back is going to be 2. And let's fill in what we have. So we know that the trip there took 3 hours. So this is a time that there, or T1, is going to be 3. So this is going to be T1. I'm just going to write this down here. This is going to be 3. And then what else do we know? And the trip back took 4 hours. So that's going to be another time, this is hours. This is going to be T2. So T2 is going to be 4. And we're still missing these 2 variables. We're asked, what was Kim's average speed on the trip there? So the trip there, let me go ahead and identify that. Speed on the trip there, let me maybe underline this. Speed on the trip there, that's talking about rate 1. And we have 30 miles per hour on the return trip. This is the rate 2. So I know rate 2 is 30. That's going to be multiplied by T2. This is going to be equal to 3 times. We don't know R1, so let's leave it R1. All right, and then this one we just simplify. So simplify on both sides. 3 times R1 is 3R1. The right-hand side of this equal to sign is going to be, let's see, 3 times 4 is 12, and then we're going to add on that 0, so 12, 0, or 120. And then from here, we just divide both sides by 3, divide both sides by 3, and R1 is equal to 40. Why? Because 12 divided by 3 is 4, and then add on the 0. So 4 add on the 0 is 40. Don't box this because we haven't interpreted this. 40 what? It's Kim's average speed, and speed is measured in miles per hour. So we can say that Kim's average speed is 40 miles per hour. We will box that interpretation and then check our work. 40 miles per hour, is that correct? 40 miles per hour for number 3 is correct. And with that problem, we are now halfway done with these problems. Problem number 3 out of 6 is done. Let's move on to problem number 4. And just as a way to think about how Mr. Sindel makes homework, if I make adjacent problems the same, I usually make the second problem harder. I strongly believe that problem 2 is harder than problem 1 because it required a second equation. I think that problem 4 is going to be very similar to problem 3, but it's probably going to require a second question. That probably brings up a question of, like, how am I going to make a quiz? I'm choosing the harder problems to put on the quiz, so just beware. Let's read number 4. A passenger plane flew to the maintenance facility and back. So if it's a question that goes there and back, then it's going to be distance is equal to distance. Let's write that down. Distance is equal to distance. And we might as well say 1 and 2 because we know that that's what happened in the last problem. And let's transform distance. We know distance is the same thing as rate times time. So I'm going to say rate 1 times time 1 is going to be equal to rate 2 times time 2. Let's fill in what we know. We have some information. It took 1 hour less time to get there than it did to get back. We're going to come back to you because I don't know how to interpret that yet. It doesn't directly plug into any of these variables that I know, so I'm going to skip it. This is information that we can plug in. The average speed on the trip there, so the trip there, speed on the trip there is rate 1, and the rate 1 is 330. So let me write this in blue. 330 times something is going to be equal to something else. All right. It also says the average speed on the way back. So if I'm talking about average speed on the way back, that's talking about rate 2. And rate 2 is going to be 264. 264. Notice our units are miles per hour, which doesn't really matter because we're looking for hours on the trip there. So we're asking for time on the way there, time 1. That's the question that we're asking for. So if that's the question, we should probably leave this T1 here. And unfortunately, it never told us up here what T2 is, so we'll just write T2. We don't have anything to plug in. And again, this is that aha moment of, oh, look at this. I have one equation with 2 types of variables. If I have 2 types of variables, I should have had 2 equations, and I only have 1 equation, which means I need another equation. So how do we make another equation? We're going to use this piece of information to make our second equation. Again, this is a difference. 1 hour less time than it did to get back. So we need to do that same thing I was talking about before, where we do something that's big, something that's big, subtract something that's small, and that will give us our difference. So which one is bigger? Which one took more time? It took 1 hour less time to get there. If it took 1 hour less time to get there, that's, again, T2, and that is less time, so that's the small time. So T2 is the small time. I'll come down here and say that T2 is the small time, and by process of elimination, there's only one other. T1 must be the big or the large time. And if I subtract that, I'll get their difference, and the difference is 1 hour. So this is going to be 1. All right, so this is one of those clever moments where instead of doing too much work, I'm going to solve for the wrong variable. I'm asked to solve for T1, so instead of solving for T1 and just adding T2 to both sides, I'm going to solve for T2. And I did say in problem number 2, I want to show you that there is a longer way to do that in case you make a mistake. I will show you how to solve for T2 to show you how to go fast, but then I'm going to go ahead and erase it and then show you that it doesn't even matter. I'll solve for T1 and I'll show you the additional step at the very end. And you can maybe decide whether or not you like the clever method or the longer method. So here's the clever method that I'll erase. The clever method is I'm solving for T2, which means I'm going to get rid of T1. If I get rid of T1 on both sides, I'm left with a negative T2, which is kind of annoying, which is equal to 1 minus T1. It's annoying because I haven't solved for T2, I've solved for negative T2. So I need to get rid of this negative. The way that we do that is by multiplying or dividing by a negative 1. I prefer multiplying, so I'm going to say that this left-hand side is going to be multiplied by negative 1, and this entire right-hand side is also going to be multiplied by negative 1. When I do that, this negative and negative will cancel out, leaving me with T2, which is going to be equal to, and you have to be very careful here, you're multiplying the entire side on the right-hand side by a negative 1, which means you're distributing negative 1 into each of these. You're going to get a negative 1 plus T1. And then from there, you could do substitution and say, hey, if this T2 is negative 1 plus T1, then this T2 is also negative 1 plus T1, and then do the substitution and be basically done. That would be the clever way. But I'll show you that it doesn't matter if you're clever, and I'll do it with brute force. So let me undo this. and show you the way that I wouldn't solve this normally. Let's go ahead and say I wasn't clever, and instead I'm like, it looks easy to solve for t1. Let's just solve for the easy one and just add t2 to both sides. If I add t2 to both sides, I get t1 is equal to 1 plus t2. And I don't have to do anything where I distribute by a -1 because it's ready to go. The substitution is ready. Hey, t1 is equal to 1 plus t2. Hey, this t1 is also therefore equal to 1 plus t2. So we're going to substitute 1 plus t2 into this t1. So when I do that, I'm left with 330 times, and here it comes, 1 plus t2, and then rewrite the rest of the equation, is equal to 264 t2. And then I solve. So again, I'm going to distribute 330 times 1 is 330. 330 times t2 is a positive 330 t2. From here, I'm going to rewrite the right side. I'm going to say 264 t2, and I need to solve. So right now, notice that I usually always start with my variables when I'm solving linear equations, and I say, okay, this side has a variable and this side has a variable, so there's not an incentive to starting with the variables, but check it out. This side has a constant and this side does not have a constant, so the left side has a constant. Let's say that the left side is reserved for the constants, and I'm going to move this to the right-hand side. And I'm feeling a little bit weird here because when I'm going to move this to this right-hand side, I should be left with a negative, and I'm pretty sure the answer is not going to be a negative, which makes me have this sinking suspicion that we have done something wrong. Let me go ahead and check my work because I'm pretty sure we should not have some sort of negative happening. Let me check my work up until now. If I added t2 to both sides, I get this equation. Sometimes I mess this up and I say small minus big by accident, and that's why I get a weird negative down here. Let me check if that didn't happen. Let me reinterpret. It took 1 hour less time to get there. Oh, I did make a mistake back here. I super apologize, guys. If it took 1 hour less time to get there, then the time to get there should be the smaller time. The time to get there is t1. These should be switched. Mr. Sindel made a mistake, and if you guys caught that before I did, you should log your extra credit. Again, I want to re-clarify for a third time why I've made a mistake. If it took 1 hour less time to get there, the time to get there is t1, and that is the less amount. It is the smaller amount. Therefore, this should not be a t2, but it should be a t1. So let me come back here and switch all this stuff out. And I'm going to say this should have been t2 minus, keep the same colors here, t2 minus t1. That actually makes my life so much easier. So let me come back and undo all of this. It's kind of cool that I found that really quickly, just to show you where I knew that I was making a mistake so that you guys can follow what I was doing. In my head, I was already doing minus 330 t2 on both sides, minus 330 t2. These are opposite signs. This is a positive and this is a negative. So you take the sign the larger, you would have gotten a negative on this side and a positive 330 on this side. The answer was going to be a negative, which doesn't make sense. How can you have negative hours? So I knew I had made some mistake. I started checking my work and I found my mistake. So I hope I'm modeling how to find your own mistakes. And with this, I'm going to keep resolving the problem. So again, this time it is actually nice to not have to be clever. I'm going to not solve for t1 because that's what I'm trying to find. I'm going to solve for t2. There's no need for me to be actually clever. Just do whatever's easiest. Just add t1 to both sides. Just add t1 to both sides, and I'm going to get t2 is equal to 1 plus t1. And then from here, if this t2, sorry, I always start here. If this t2 is 1 plus t1, then this t2 is also 1 plus t1. So I'm going to substitute 1 plus t1 in for this t2. So I'm going to rewrite the equation. 330 t1 is equal to 264 times not t2 anymore, but 1 plus t1. From here, I'm going to distribute. 264 times 1 is equal to 264. And then I'm going to multiply 264 times t1. I get a positive 264 t1. And the left-hand side hasn't moved. It's still 330 t1. Notice what we've done. We have one equation with one type of variable. There's two variables, but they're the same type of variable. We're ready to solve. Again, notice we have variable on the left, variable on the right, so there's not an incentive to start with the variables. There's a constant on the right, and no constant on the left. So let's go ahead and say, hey, the right side is reserved for the constants. You're right in the right spot. This is in the wrong spot, so we need to move 264 to the left side by subtracting 264 T1 on the right and subtracting 264 T1 on the left. When I do that, this is what happens. These cancel out, and I'm left with 264 on the right, and on the left side, what is that going to be? 66, it looks like, 66 T1. Let me just double check my math. If I do 36, that goes up to 300, and another 30 gets up to 330, so that's 30 plus 36, which is 66. Okay, and then finally, do our last step of getting rid of this pesky 66 T1 and doing dividing by 66, and this is going to give you T1 is equal to, what is this going to be? 264 divided by 66. I'm guessing it's about 4. Let me just double check. Is 4 times 66, what I'm hoping to get here, is that equal to 264? Because if it is, the answer is going to be 4. That's my guess. Let's go ahead and verify that that's actually the case, though. So I'm going to say 6 times 4 is 24, carry the 2, 4 times 6 is 24 again, 25, 26, 264, and that is indeed the number I'm looking for. These are the drawers you're looking for, and we are almost done. Let's make sure we have the right thing. We're looking for T1, the number of hours the trip there took. And the T1 is 4. So let's make our interpretation for what? 4 hours, because that's the hours that we're looking for. Final answer, box it. We made a mistake, but we caught it before we even got to the answer. Normally, I would be highlighting that mistake in purple, but because I caught it, I'm going to go ahead and not write anything in purple. And let's check. 4 hours for number 4, 4 hours for number 4. And I can highlight that one in green. Good job, Mr. Sindel. All right, 2 problems left. Number 5 should be a little bit easier, and number 6 should be a little bit challenging. So let's go ahead and read number 5 and figure out what type of distance problem we have. So I have Air Force plane leaving Nairobi and flying towards Dublin. It doesn't really help me. And a jet left flying and trying to catch up. Okay, so whenever you have a sort of catch-up problem, and we're also having a catch-up problem in number 6, and I'm not saying like mustard versus ketchup. I mean like catch-up as in you're trying to catch the person that's in front of you. It's always going to be a distance equal to distance. You're still traveling the same distance. The start is the same spot, and you're going to eventually catch up to them. The point that you catch up to them, you're both traveling the same distance. Therefore, you are going to have a distance is equal to distance problem. Over here, this is also going to be a distance is equal to a distance problem. And more specifically, we need to reclassify this as a rate times time is equal to a rate times time. This is not a there and return trip, so we need to have a little bit better variables. We have an Air Force plane, and we have a jet. So let's maybe make our variable A for Air Force plane and J for jet. So I'll say RA and TA and RJ and TJ. So I know one is the Air Force plane and one is the jet. All right, let's go into this equation and see what we've got. So we have 1 hour later. Again, this is a difference amount, so this will probably be used for maybe a second equation, or maybe there's a clever way to not have to use a second equation. Usually number 6 is going to be the second equation. And it says, hey, the jet is leaving and traveling 360 miles per hour. So that's the rate of the jet. So I'm going to come down here and say that this is 360 times something else. There's an equal to sign. What else do we have in here? After flying for 4 hours. Okay, so the jet travels for 4 hours. That's what this is saying. After flying for 4 hours, the jet finally caught up. The jet flies for 4 hours. The time is 4 hours. This is going to be 4 over here. All right. Well, this is bad because I still have two variables. Can I somehow use this information up here to not have to do 2 variables? It says 1 hour later a jet left. Well, if the jet left 1 hour later and the jet traveled for 4 hours, that means that the Air Force plane has already been flying for 1 hour and another 4 hours, and then it eventually gets passed by the jet. So it's 1 plus 4, it's 5. The time for the Air Force plane should be 5. And then the thing that I don't know is the rate of the Air Force plane. The rate of the Air Force plane, which makes sense, right? Let's find the Air Force plane's average speed, which is the rate. So all I need to do here is solve for rate of A, and I'm done. So how do we do that? The first thing that I'm going to do, can I show you guys a cool trick? My first instinct, by the way, was to multiply 360 times 4, but then I immediately got scared because that's a big number. So I was like, is there a way around having to do that? And there is. because I know eventually I'm going to have to get rid of this 5. The way that I undo multiplication is with division. I know I'm going to divide by 5. Well, let's just do it now and watch what happens. If I divide the left side by 5, I have to divide the right side by 5. And I'm basically done isolating r of a. The problem is I need to somehow figure what this is, and I prefer not using a calculator. Will I allow calculators on the quiz? Yes, because I think that the hardest part of these problems is the problem-solving techniques and setting up the problems. I don't think that this calculation is the hardest part, so let's just use a calculator. That's not what I'm assessing. And you might say, okay, well, 4 divided by 5, that doesn't help. But here's the thing that does help. Instead of having a giant number divided by 5, I have a slightly smaller number divided by 5. So I want to purely focus on this problem, and then we'll multiply by 4 at the very end. So how do I do 360 divided by 5? That's the same thing as doing 360 divided by 10 and then multiply by 2, because this divide by 10 times 2 is the same thing as divide by 5. You could cross cancel these by dividing the top and bottom by 2, and this would be 2 and 2 would go away, and 10 divided by 2 is 5. So this is the same thing, and this is an easy problem to do. When you divide by 10, that's equivalent to crossing out a 0. Cross, cross. That's 36 over 1, which is 36. Now I just have to double 36, which might be a little bit hard for some people, but I can clearly see is 72. So this answer here is 72. So what I'm saying here is this is 72. I'm going to come down here and say this is 72, and then I still have to multiply by 4. And multiplying by 4 has another trick, which I can show you right now. To do 72 times 4, anything times 4 is just times 2 times 2, a double. So I can double things pretty quickly in my head, because I can double 2, and I'll just write it down, 4, and I can double 7, and I get 14, so 144. That's a double. I need to do a double, so I need to double this again. And that's actually going to be written as my final answer, right? Double 4, you get 8. Double 4, you get 8. Double the 1, you get a 2. And the answer should be 288. 288 what? So again, we were looking for the Air Force plane's average speed. And what is speed measured in this problem? It says this rate up here was the speed of kilometers per hour. So this should be 288 kilometers per hour. My final answer is going to be 288 kilometers per hour. Final answer, box it, and let's check the back, see if we got it right. My H could be extended a little bit. There we go. 208 kilometers per hour, 208 kilometers per hour. So far, so good. And we're going to highlight that one in green. We are on to our last problem, ladies and gentlemen, number 6. I already know that it's going to be a distance is equal to a distance, because it's going to be one of these catching up type of problems. So we might as well relabel this with rate times time and leave some room, because I know I'm going to have a second equation, because this should be the harder one. It's going to be a rate times time is equal to a rate times time. Okay, so we need some better names. And in problems number 3 and 4, we had 1 and 2 for our variable names. These are going to be different. So we have, unfortunately, Aaliyah and Adam, both of them starting with an A. I'm going to use the second letter of their name for my variables. So I'm going to have an L and a D. That way I can distinguish between them. So I'm going to say L and L. I do a cursive L, so does that look like an L, or does it look like a 1? So I do cursive L's instead of 1s, so you can always distinguish between Mr. Sandell's L's and his 1s. So L's and D for Adam. Okay, let's see what information we can automatically just fill right into our equation. So let's read. Aaliyah, that's going to be L for Aaliyah. She's leaving the mall and traveling toward the lake, and here's a speed. The speed is 40 for Aaliyah's rate. So 40 is Aaliyah's rate. I can immediately plug in 40 down here. 40 times something is equal to something times something. What else can we plug in? Adam left 1 hour later. Okay, we'll probably have to come back for that and make a second equation out of the 1 hour later, because that's a difference amount. Whenever you see the word later, that means difference. And he's traveling in the same direction, and it says the average speed, so this is a rate. The rate for Adam is going to be 48. I'm going to plug in 48 for Adam's speed. And you'll notice that the rest of this doesn't help us at all. It just says, it asks the question, find the number of hours Aaliyah traveled before Adam caught up. We don't know anything else, so we just have to copy down this variable. When I copy down that variable, it's kind of sad. We say Aaliyah's time and Adam's time. We have one equation with 2 variables. 2 variables means 2 equations. I need to have some sort of a secondary system here, a second equation. So how am I going to relate the 2 different times? Well, it's this piece that I told us we would come back to. Adam left 1 hour later. Okay, in problem number 4, I made a mistake. I'm going to spend an extra amount of time making sure I do not make a mistake over here. Again, I should always be doing big minus small to get the difference. Okay, I know what the difference is. The difference is 1 hour later. So the difference I can automatically say is 1. Which one is the bigger, though? So if Adam left 1 hour later, that means Adam is not traveling as long. Aaliyah has been traveling for a while already, and then Adam is going to travel less time. Aaliyah's been traveling for 1 hour, and then after 1 hour, then Adam leaves. So Aaliyah's been traveling for 1 hour more, therefore Aaliyah is the bigger time. So bigger time is Aaliyah, bigger time is Aaliyah. Come over here and say this is going to be T for Aaliyah minus T for the other one, which is Adam. All right, so I need to analyze how to be clever in this question. Which one are we trying to find? We're trying to find the number of hours Aaliyah traveled. And then Adam, we don't really care about that much. So Aaliyah's time is going to be TL. If I'm being clever, what I want to do is I want to solve not for TL right here, but I want to solve for TD. And finally, I have a chance to show you it does not matter which of these two variables you solve for. I'm going to solve for the easier one, which is wrong in this case. It's not wrong, it's just not as efficient because I'll have to do an additional step after I do all my equation solving, but that's okay. Here, I'll show you how to do it now. So I'm going to just add Adam's time to both sides. I'm going to add Adam's time to both sides. And when I do that, you're gone. I'm left with the time for Aaliyah, and that's going to be equal to 1 plus the time for Adam. And here's the statement again. If TL is equal to 1 plus TD, then this TL is also 1 plus TD. So this 1 plus TD is being plugged in for this TL. And we're going to rewrite this equation. It's going to be 40 times, not TL, but 1 plus TD. And this is going to be equal to 48 times still TD. And I'm saying TD, but it's really Adam's time, right? And then I just solve. I'm going to say 40 is being distributed. 40 times 1 is 40. 40 times TD is going to be a positive 40 TD. And then on the right-hand side, 48 times TD is 48 TD. All right, let's first analyze our variables. Variable on the left, variable on the right. Okay, it doesn't matter which side the variables are. Let's analyze the constants, aka the numbers. There's a constant on the left, no constant on the right. Therefore, the constants should probably live on the left. If the constants are already on the left, we need to move the variables to the right-hand side. Let's do that. So I'm going to subtract 40 TD on the left, which means I subtract 40 TD on the right of the equal to sign. Okay, this is going to be canceled, and I'm left with 40 on the left of the equal to sign, and on the right side I have 8 TD. And then from there, I need to undo this multiplication by 8, and I'm going to divide the right side by 8, divide the left side by 8, and this is going to be just TD by itself is equal to 40 divided by 8, which is 5. Here is the problem. What were we asked to solve for? Were we asked to find Adam's time? We were asked to find Aaliyah's time. So this is great, but we need to do one additional step before we do our interpretation. Adam's time is 5 hours, but we know that we're trying to find Aaliyah's time. This 5 is TD, which means this TD is also 5. I'm going to plug in 5 here, and I'm going to ask this obvious question. What number minus 5 is 1? And the answer is 6 minus 5 is 1, which means Aaliyah's time is 6. So come down here and say, Aaliyah's time is therefore 6. And I can answer the question finally, and I can say that Aaliyah's time is 6 hours. And I can box 6 hours. Let's check the back. Number 6 is indeed 6 hours. We got the right answer. Let's come down here and highlight this in green. I made one mistake in problem number 4, but we cut it before the problem even finished. We've done all 6 problems of homework 1-6. Thanks for watching. I'll see you guys later.